Consider the function f of x equals x squared. Here's a graph. We know that this is just your standard parabola. And one of the questions we want to look at is, how do we find the equation of the tangent line to a curve? So for example, if we have a point here and we draw a tangent line through that point, how could we find the equation of this line? So one thing that we had been doing was we would take that point, we'll call it point P, which has coordinates of 2, 4, and then we would pick another point, say this point over here we'll call point Q, and Q has coordinates -1, 1, and then we would find the slope of the secant line connecting those 2 points. And so the slope of the secant line is change in y over change in x. So change in y, f of 2 minus f of -1. So f of 2 is 4 and f of -1 is 1. And so I can substitute that in, and then I would get 3 over 3, or 1. And then I would take another point, say this point down here, and we'll call this point Q now, which has coordinates of 0, 0. And I would do this over again. I would take the secant line, I would find the slope of the secant line, I would get a number, and then eventually, as I kept taking points closer and closer to point P, I would see that I would start to get a slope that approaches a certain number. And then I would take this number to be the slope of the tangent line. And then once I know the slope of the tangent line, I have the point P and I have a slope, I can get the equation of the line. So having something that approaches something else sounds an awful lot like a limit. So let's look at this in a little bit more detail. Here is some function, we'll say, and we have a point P and we have a point Q, and I've drawn a secant line through points P and Q, and I've called the secant line L. And so let's say that this has a coordinate of A, this point P, which means that this y value over here I can write as f of A. If this is the function f of x, this would be f of A. And I'll say that this is some other point x over here with x coordinate x, which means for point Q it has a y coordinate of f of x, where x then is some number. But I'm going to let this number change by letting Q get closer and closer and closer to point P, just as I was doing before. So that's why I've chosen x here, because x you think of as a variable typically, and that's the thing that's changing as I move point Q closer to point P. This x down here will get closer to A over here. So here's the formula for the secant line. That was f of x minus f of A divided by x minus A for the slope of the secant line L. And I notice that as x gets closer to A, so on the x-axis here, as this x gets closer and closer to A, I notice that the slope of the secant line gets closer and closer to the slope of the tangent line. So the slope of the tangent line is actually the limit as x approaches A of f of x minus f of A divided by x minus A. So let's go back to the parabola that we had before, and we were trying to find the equation of the tangent line to this function f of x equals x squared at the point 2, 4. And so I have my equation of the tangent line right here. And so here is the point 2, 4, this point right here, and we can pick another point, say some point that's over here, and I can say that this is the point that has coordinates of x and f of x. And notice, since we're taking the two-sided limit, it doesn't actually matter whether you come from the left or from the right here. Both of them should work. So in this case, I've chosen this point right here, and the idea is to imagine this point getting closer and closer and closer to this other point, which means x will get closer and closer and closer to 2 right here. So how do we calculate this? Well, the slope of the tangent line is given by this formula up here, so it's the limit as x approaches A of f of x. Well, what's f of x? That's x squared minus f of A. What's f of A? Well, A in this case is 2. So f of A would be 2 squared, or 4. Okay, and then we have x minus a remember is 2. Okay, so this a right here, we can actually think of this as 2. Okay, and so what can we do with this limit here? This is something where if we plug in 2, we get a 0 divided by 0, but I can factor the top here. So let's rewrite that as the limit as x approaches 2 of, and this factors as x plus 2 and x minus 2, all over x minus 2. And now I can rewrite this as the limit as x approaches 2 of x plus 2, canceling out the x minus 2 factor. And I can plug in now for the 2. 2 plus 2 is 4. Okay, so that's the slope of the tangent line. So I have a slope here. The slope is 4. I also have a point. The point that I know is on the tangent line is that point right here. This is the point, one point that I do know on the tangent line, 2, 4. And once I have a slope and a point, I can find the equation of the line. So the general equation is y equals mx plus b. M is the slope and b is the y-intercept. Well, I know the slope, that's 4. So this is y equals 4x plus b. Now to find b, I can use the point. This is an x-coordinate and this is a y-coordinate. So 4 equals 4 times 2 plus b. So 4 equals 8 plus b. And so that tells me if I subtract 8 from both sides that b has to be negative 4. So the final equation of my tangent line is y equals 4x minus 4. And if you think about it, that seems about right. If we were to draw in a tangent line here, it looks like maybe it would hit the y-axis somewhere down here, maybe at negative 4. And it would have a positive slope, and a slope of about 4 looks to be about right. Let's look at one more example. Find the equation of the tangent line to the function f of x equals the square root of x minus 2 at the point 6, 2. Here is a graph of this function. So it's your square root graph that has been shifted to the right by 2 units. And here is the point 6, 2. That's this point right here. And so we can imagine taking some other point, maybe this point right here, and I'll say that this has coordinates of x, and then this over here would be f of x. And also keep in mind that in what I'm using this formula up here for the tangent line, that this is really my a, and that this is really my f of a, this value of 2 right here, if I can draw a dashed line across. Okay, so to actually calculate this, I'm going to imagine bringing this point closer and closer to this other point here, meaning x is going to get closer and closer and closer to a, and when that happens, the slope of the secant line will look more and more like the slope of the tangent line. So let's try and find the slope of the tangent line. So the slope of the tangent line is the limit as x approaches, in this case, 6, of f of x minus f of 6 divided by x minus 6. Okay, so what is this? Well, I can actually plug in now for the f of x and f of a. F of x is, well, that's the formula right here. F of x is square root of x minus 2. Okay, so this is square root of x minus 2 minus, and this must be the square root of 6 minus 2. That's what f of 6 would be, all over x minus 6. Okay, and so this equals the limit as x approaches 6 of the square root of x minus 2, and then we have the square root of 6 minus 2. 6 minus 2 is 4, and the square root of 4 is 2, so this is minus 2 over x minus 6. If you plug in 6 here, again we have a 0 over 0 situation, and so for a limit that has a square root in it, remember the trick that you use is you multiply the top and bottom by x minus 2 plus 2 in this case, and that will get rid of the square root in the numerator. So let's try that. So when I actually do this out, I'm going to leave the bottom just as it is. I'm not going to multiply it out, so I'm going to leave it as x minus 6 times the square root of x minus 2 plus 2. And the numerator I am going to multiply out. So square root of x minus 2 times square root of x minus 2 is plain old x minus 2. And then I'm going to get square root of x minus 2 times positive 2, and I'm going to get square root of x minus 2 times negative 2. Those are going to cancel. And lastly, I'm going to have negative 2 times positive 2. That's going to be negative 4. And so you see that the top is really x minus 6, and that's going to cancel with this x minus 6. So this is really just the limit as x approaches 6 of 1 over the square root of x minus 2 plus 2. And now I can plug in. So if I plug in 6 into this, I get the square root of 6 minus 2 plus 2. All that underneath 1. And so this again is 4. The square root of 4 is 2. 2 plus 2 is 4. This is a fourth. Okay, that's the slope. Now I need to find the line. So I have the point 6 comma 2, and I have a slope of 1/4. So I can use my general equation of the line. I'm going to plug in the slope here, 1/4 x plus b, and to solve for b I'll use the point 6 comma 2. And so this is 2 equals 1/4 of 6 plus b, which is the same thing as, well, 6 over 4 is the same thing as 3 over 2 plus b. And so b must be 2 minus 3/2, which is the same thing as 4 over 2 minus 3/2, which is the same thing as a half. So the final equation of my line is 1/4 x plus a half. And if you take a look at the graph and imagine what a tangent line here would look like at this point, it would have a positive slope of about 1/4. That seems about right. And then it would hit the y-axis at a half right about here. Yeah, that seems to make sense.